Welcome to this series of introductory lessons related to the time value of money. My name is Brent Pritchard. I teach college finance courses, and I'm here to help you grasp this all-important concept. This introductory series is designed to help you learn how to apply the mathematics of finance in less than a month, provided you commit to one or more lessons a day. It's that easy. Acquiring the hard skill that is the mathematics of finance does not need to be hard. I hope you enjoy this fun new take on this age-old concept. And after you've done that, please consider telling your friends about this channel, TVM Rules, and the book, Would Your Boomerang Return, also known as the Boomerang book that made it possible. I like to start every class with a quote, so here we go with the quote of the lesson, which has been attributed to Abraham Lincoln. Give me 6 hours to chop down a tree, and I will spend the first 4 sharpening my axe. The focus of this lesson is how to deal with a change in how you're telling time on the timeline and the corresponding change for the true investment yield. Now, I'd be remiss if I didn't mention that you might also encounter situations where the true investment yield changes regardless of whether there's a time change. It's worth revisiting the definition for the variable uppercase N. This variable can be thought of as the investment period that it is. However, there are situations where uppercase N won't be equal to the total investment period. And that's the case when a time change occurs. So here's the real world situation for this lesson straight from the book, Would Your Boomerang Return? So let's summarize this real world situation. You've got friends, you probably have a lot of them, and these friends want to retire 20 years from now. Over the next 10 years, they want to save $12,000 each year with a single deposit every year, with the first deposit starting 1 year from now. They've got $25,000 saved already. And then for the second 10-year period, they're going to up their savings rate and they're going to save $24,000 a year. We're given the simple annual investment yield, so simple is false in my book, so we need to determine the true investment yield, and that'll be one of the things that we do. But we also want to determine that PMT payment. So what are they going to be able to withdraw from this savings account on a monthly basis? That's where the time change occurs over their 30-year, or better said, 360-month retirement period. So let's get about drawing the TVM wallet, and we're actually going to draw 4 TVM wallets for this real world example, but we have the slides for that, so let's start right here. So we draw our TVM wallet. Remember, the TVM wallet, it's our solution to analysis paralysis. It gives us the 3 simple steps that we need to analyze and evaluate real world time value of money situations. So the first thing that I'm going to do is write in the 5 primary time value of money inputs or variables, the keys on your financial calculator. And in the first window of the TVM wallet, let's visualize. And so we're going to draw this out. There's the abridged symbol. Another abridged symbol, a third abridged symbol. There we go. So we want to determine, well, we've got a time change. So what I'm going to do off here to the left is I'm going to write an A here and a colon to show us that we're telling time here with our timeline with an annual time span in between period markers. You know, this is how we usually do it. We fill in the blank. So we'd fill in the blank here with an uppercase A, but we're going to change it up this time because we also have a parallel timeline above our timeline with a monthly time span in between period markers on the timeline. But that doesn't take effect until we get 20 years out. And so right here we have 239 months from today. We're going to extend these time period markers. This is 599 months from today. and this is 600 months from today. So we have parallel timelines here. And we have 25,000, or your friends have $25,000 in the bank, so we've got a negative sign in front of that 25K, and they plan to save $12,000 a year for the first 10 years, with that first payment starting a year from today. And then they're going to up their savings rate to $24,000 for the second 10-year investment period. Remember, sometimes an investment period isn't the total investment period. So what do we need to do here? Well, first of all, we need to do a couple things. There are a few intermediate steps here. We need to determine future value here, and we need to determine the future value for not only this second annuity, but for all of the monies that would have been saved prior to that period in time. And we need to determine the present value. And then last but not least, we need to determine I'm going above the timeline here just to find some space. I'm circling PMT payment because that's ultimately what we're solving for. That monthly withdrawal that we're going to be able, your friends will be able to take, maybe they'll give us some, wouldn't that be nice, during their 30-year planned retirement. And that first withdrawal is going to happen 240 months from now. The last withdrawal will happen 599 months from today. So let's get about solving for the true annual investment yield. So here's the building block true investment yield equation. You've seen this before if you've been following the lessons. And so we were provided with a simple annual investment yield of 6.785%. So this is that in decimal form. We were told that compounding happens monthly. So lowercase c takes the value of 12. Why 12? Because S has an annual duration, so that's the time span for the simple investment yield. So S is what I call the caterpillar rate. Kind of looks like a caterpillar, right? When we divide by C, what do we have in parentheses? That kind of looks like a chrysalis. That's a chrysalis rate. And we don't need to know the number now. We just need to call it by name. So we started with a simple annual investment yield. When we divide by 12, we have a what? A simple, fill in the blank, monthly investment yield. And if we want to take this to a true annual investment yield, we have to ask ourselves the right question. And that question here is how many months are in a year? And we know that that's 12. So lowercase n takes the value of 12. And when we subtract 1, we get 0.07 or 7%. And that's the true annual investment yield. So we're going to be plugging in 7%. It's actually 7.00028%. And we'll see that later with a slight rounding error, but we're going to plug in 7% here. We'll put an A in the subscript for uppercase N to remind us how we're telling time here. And for this first step, we have a lump sum amount in savings. It's $25,000. So we have a negative sign associated with that. Why? Because it's not in your hands. It's in a savings account. It's earning money. And we also have a PMT payment. So this is negative $12,000. So that first PMT payment is going to, or deposit, is going to be made 1 year from now. And then we calculate the future value. And the future value here is $214,976.50. Oh, I should have put a 10 in here for uppercase N. So we've calculated future value. as of the end of the 10th year, or the end of the 10th period. So that's the first step. Now to the second TVM wallet. We're going to build on the first. Again, I'm going to write in the 5 primary TVM variables, the inputs on your financial calculator, or the keys on your financial calculator, the inputs for the building block time value of money equations. And now we need to fast forward a little bit, because here's where we are on the timeline. And so this is an abridged timeline. And again, we're telling time with an annual time span in between period markers. We solved for this amount already. So this is the expected amount that your friends will have in savings 10 years from now. And then they're going to start saving $24,000 one time each year to take them 20 years to 20 years from now. So then the next thing that we need to do is to determine the future value. I'm going to put a rectangle around that because that's not ultimately what we're solving for. We're still telling time with an annual time span in between period markers. So I'm using an uppercase A in the subscript for N. The true investment yield is still a true annual investment yield of 7%, so that hasn't changed. For N, we've got a value of 10 once again. The PMT payment will change to $24,000. We've got a negative $214,976.50. And now let's solve for future value. $754,487.59. So we've solved for the future value, the expected amount that your friends will have in savings 20 years from now. So that's the second step. Let's move on to the third TVM wallet. There are the 3 windows. In the second window, I'm going to write in lowercase I and uppercase N. In the third window, we have our 3 different payments. PV and FV relate to a lump sum or a hypothetical lump sum. PMT payment relates to an annuity or an annuity on steroids in the case of a perpetuity. And so now let's look at what we have here. Now we've made the switch. 240 months from now, 239 months from now. I'm going to put this in parentheses because this was the way that we were telling time with an annual time span in between periods. I mean, this is still 20 years from now, so it's good to put that 20 in parentheses, I think, to kind of keep things straight. So we've switched our timelines now. Now the monthly timeline is front and center, and we find that here with the time period markers because this is where we're going to do our work. So we calculated $754,487.59 in the last TVM wallet. But now what we want to do is to calculate the present value. And why do we want to calculate the present value? Well, we want to calculate the present value because we're really looking for the present value of an ordinary annuity. So I'm putting OA in parentheses there. We're solving for the PMT payment, but that'll be in the next TVM wallet that we work with. So I'm going to, and again, the TVM wallet is meant to be used in conjunction with your financial calculators. So wherever you are, if you're at home or on the road, hopefully you're following along with your financial calculator. And here we have 1 period. But we need to put an M in the subscript for uppercase N because this is 1 month. There's 1 month in this discounting period. Now, because we've had a time change, we've also had a change to the true investment yield. So let's go back to drawing the building block true investment yield equation because we need to account for this change. 0.06785. That's the Caterpillar rate. What is it? 6.785%. That is a simple annual investment yield. There are 12 compounding periods over the course of a year. When we divide by 12, we're left with a simple monthly investment yield, but it's still simple. That's the chrysalis rate. And so how do we take a simple monthly investment yield and turn it into a true monthly investment yield? Well, lowercase n takes the value of 1. So when we raise that to 1 and subtract 1, we get 0.005654, and I have just enough room. In my trusty HP12C financial calculator, I need to input that as a percentage. 0 for PMT payment, because we'll solve for the PMT payment in the next TVM wallet. And when we solve for what ultimately is the present value of an ordinary annuity, we get negative $750,245.58. So we're almost there. We've had the time change, and now we're at the last step. The last step is to determine this PMT payment. What are your friends going to be able to take out every month for what they call walking cash? Because this is one of a few retirement accounts your friends have. And this is their spending money. So 239, 240, there's a break, that's the abridged symbol, 599 and 600. So this is 50 years from today. This is 20 years from today, and they have a 30-year retirement plan. We calculated the present value of an ordinary annuity in the last step, so that's 750, 245, 58. That goes right here. That's the end of the 239th month. 239th month. And we want to figure out what is the payment that goes from the end of the 240th month through the end of the 599th month. So they're going to take out the withdrawal at the start of the month. So we calculated the true monthly investment yield, and that is 0.5654%. 0 for future value. Why 0? Because they are going to completely exhaust this walking money savings account. Good for them. And we have 360 months. There will be 360 PMT payment withdrawals. And when we solve for PMT payment, we get $4,845 $33.55. That has a positive no sign value. Why is that? Because those are monies that are going to be withdrawn from this account. Those are monies that are going to flow into your friends' hands, and so signs matter. So let's double check our work like we do. And first we're going to work with the building block future value equation. Future value equals present value times 1 plus I, that's the true investment yield, raised to the power of uppercase N. Remember, sometimes uppercase N considers the total investment period. Other times, like in this case, it doesn't. But it is an investment period. It represents an investment period. Okay, let's take this out to the end of the 10th period. Future value equals $49,178.78. So I'm going to circle that. So that's the amount that they have in savings right now. So what is that $25,000 expected to be worth 10 years from now? Well, remember, 7% is the true annual investment yield. So that's why we raise that to the power of 10, and we get this $49,000 and change, a lot of change. And I'm going to round there just in the interest of time. So now let's move on to the future value of an ordinary annuity. And this is the equation. The building block future value of an ordinary annuity equation. 1 plus I raised to the power of uppercase N minus 1 with the true investment yield in the denominator. And so when we solve for this, here are the inputs. 1.07 raised to the power of 10. Why 10? Because there are 10 PMT payments in this series over the true investment yield. That's a 7%, 0.07. When we solve for the future value of the ordinary annuity, we get $165,797.38. So when we add those two circled amounts together, we get $214,976.16. So let's plug this value into the future value, the building block future value equation, and let's take it out to the end of the 20th period, so 20 years from now. Why does the value for uppercase N take a value of 10 here? Well, because we're already at the end of the 10th period, so we want to compound these monies an additional 10 years, and so that's why we raise this 1.07 to the power of 10. And when we solve for future value, we get $422,890.64. So that's a value that we can circle. Okay, let's move on to the next double check, because we're working our way there. And we're going to once again use the building block future value of an ordinary annuity equation. I wrote this already, but it's worth writing it again. 1 plus I raised to the power of uppercase N minus 1 over the true investment yield equals, now we've got a $24,000 PMT payment. 1.07 raised to the power of 10. Why? Because there are 10 $24,000 payments in this series, minus 1 over the true investment yield. And when we solve for the future value of this ordinary annuity, we get $331,594.75. So we're going to circle that. When we add that amount to the future value that we just calculated on the last slide, it's a 4, we get $754,485.39. So we're off by just a little bit. And again, that's due to rounding, because technically the true annual investment yield is 7.000028%. And so we're going to be off by just a little bit. Okay, let's draw another squiggly line, because remember that present value step that we had? So we're going to use the building block present value equation. Present value equals future value over 1 plus I raised to the power of n. So here we have present value equals 754,485.39 over 1.005654. Now that's a true monthly investment yield, and we want to discount these monies back one period in time, and that's where uppercase N takes the value of 1. Again, that is an investment period. That's the way to think about it. It's not the total investment period, but here uppercase N has the value of 1, and when we solve for that, we get a present value of $750,243.39. So we're going to circle that present value, and we're really close to solving for the PMT payment. So here's our last double check slide. And on this slide, we're going to be using the building block present value of an ordinary annuity equation. And here's how we write this equation. 1 plus I, that's the true investment yield raised to the power of uppercase N, minus 1. Got the same thing down below, but here we multiply by the true investment yield. Present value of an ordinary annuity, well, guess what? It's known here. We just calculated that. $750,243.39. 39 cents. We're solving for the PMT payment. So we want to know PMT. 1 plus, I need to make sure I have enough space here, 0.005654 minus 1. I haven't forgotten about uppercase N. What is it? How many PMT payments are in this series? 360. 1.005654, once again raised to the power of 360, times 0.005654. I'm just going to work this down before rearranging it. Equals PMT payment times everything here in the square brackets comes out to 153.627219. And then when we rearrange and we solve for the payment using algebra, put this over 153.627219, we get the PMT payment equals $4,000. $883.53. Now, it was 55 cents. It's off slightly because of rounding. My 2 cents about this, and you can't make this stuff up. It just worked out to be off by 2 cents. But my 2 cents is don't transpose values from paper or from your financial calculator. When you're determining the true annual investment yield or the true monthly investment yield, don't just plug the numbers and determine it and then clear it out and transpose. Keep that value in that register, because in some cases you're going to find a couple digits way off to the right, and you want that to be picked up by the math. So again, just my 2 cents, but we got what is essentially the correct answer. So well done. That's a wrap. If you like what you learned in this lesson, please consider telling your friends about this channel, TVM Rules, and the book that made it possible. Would Your Boomerang Return was written so that you can figure out the mathematics of finance while I sleep. Runners don't get fit by staring at a pair of running shoes in the corner, and aspiring and current finance professionals need to do the hard work. One step takes a runner across the finish line. One swing of an axe chops down a tree. And a $5 bill reminds us that there are 5 fundamental building block time value of money equations. These and the other building block time value of money equations can be used to double check your work or to analyze and evaluate real world time value of money situations using nothing more than a pen or pencil, paper, and basic financial calculator functions. If you haven't purchased your copy yet, all the important information on this all-important topic is gift wrapped within the cover of Would Your Boomerang Return. Until next time, enjoy the gift that is the present.